Hello everyone, today we're going to introduce a model used for flood inundation prediction. This is the photo for the downtown Calgary with the river running through the city. Why planners are interested in this analysis? Calgary is a city which is vulnerable to flooding in the past years, especially during May to July when we receive the largest rainfalls and are most likely to experience flooding. This model uses the latest machine learning technologies as well as the current topography data to explore various factors which could significantly affect the model inundation in Calgary. After finishing all the data wrangling and exploration, all the datasets transferred into logistic modeling process, which will generate a binary result, flood or non-flood. As we mentioned before, the model will eventually be implemented in Edmonton City as a way to predict the flooding issues. How do we combine all the citywide dataset? We build up the fishnet as each cell represents one unit. Then we aggregate all the dataset and show the majority or mean value for each cell. What are some important features? We use the digital elevation model to create the elevation map. Slope is also created by digital elevation model data since we believe the topography has tremendous impact on water flow and flooding. We use DEM file to calculate the flow direction as well as the flow accumulation in order to create the stream network. In our model, we find out two large watersheds in Calgary and calculate the flow lengths to downstream since downstream areas are more vulnerable to the flooding. Additionally, stream order is created based on the flow direction. In this case, we decide to build some features including the distance to the main stream, as well as the distance to all the stream network. Next important feature is land cover. The data is divided into impermeable, permeable, and natural land. Last but not least, we use R to classify satellite imagery and create 4 categories: water, undeveloped, developed, and cloud. Again, we bring back the fishnet as the method to incorporate the dataset. 3 additional spatial features are created. Relative elevation, relative slope are based on the data in 5x5 fishnet cells. The right diagram shows the distance from the nearest water features, which created by classification satellite imagery. We run the logistic regression and get these most significant variables, which are highlighted. Cross-validation, including training and test models evaluation, shows the probability of flood or non-flood density. The left diagram shows the highest density, which is near 0.1. Therefore, the threshold for inundation is 0.1. We also evaluate the model by checking the ROC curve. The AUC value is 0.97, which is extremely high. Typically, the higher value AUC has, the better performance the model has. Finally, we create this left diagram showing the true positive, true negative, false positive, and false negative. And we can find out that most errors occur in the upper stream. The right diagram shows the predicted probability for flood inundation. Eventually, we use our model to predict Edmonton flooding issue. Right diagram showing the predicted probability for flooding. As we can see on this diagram, the center downtown area and the northeastern part of Edmonton are more vulnerable to inundation. Thank you.